For example 1, we need to show that the interval -1, 1, closed interval -1, 1 is the largest interval centered at the origin, for which f of x is strictly monotonic. Now, with the vertical line test, we clearly see that this interval is the largest one centered at the origin. However, we're going to use algebra to demonstrate that is true. F of x is equal to x cubed minus 3x. F prime of x is equal to 3x squared minus 3. F prime of x equal to 0. Therefore, we have 3 times x squared minus 1 equal to 0. And x squared minus 1 is equal to 0. X is equal to plus or minus 1. We need to find the zeros of the derivative in order to show that the function is either increasing or decreasing within the entire interval, therefore monotonic. Now the zeros are -1 and 1. When we're gonna test for 0, when x is equal to 0, the derivative is negative. X squared minus 1, 0 minus 1 will be -1. And when x is equal to 2 or -2, the derivative is positive. Therefore, from -1 to 1, the function is negative throughout, so the function is constantly negative. The closed interval -1, 1 is the largest interval centered at the origin, which is 0, for which the function is constantly decreasing, therefore monotonic. For example 3, we need to calculate the inverse of f of x when x is equal to 3. First, we're gonna show that f of 2 is equal to 3. Starting with f of x, we're going to calculate f of 2, which is 1/4 times 2 to the third plus 2 minus 1. Now f of 2 is equal to 1/4 of 8. 2 to the third is equal to 8 plus 2 minus 1, which is really 2 plus 2 minus 1. 8/4 is 2, which is 3. Here's what we have. In the function, the point 2, 3 has the point 3, 2 for inverse. Therefore, the inverse of f of 3 is equal to 2. So we took care of A. Now for B, they're asking you for the derivative of the inverse of f of x when x is equal to 3. The formula says that the derivative of the inverse of f of x is equal to 1 over the derivative of f of the inverse of f of x. I will explain the formula in another video. Anyway, it means that the derivative of the inverse of f of 3 is equal to 1 over the derivative of f of the inverse of f of 3. The inverse of f of 3 was previously calculated is equal to 2. So it's going to be equal to the 1 over the derivative of f of f of 2. Now we're going to calculate the derivative of f of x, the general function. The derivative of f of x is equal to 1/4 times 3x squared plus 1. Now, the derivative of f of x at 2, so the derivative of f of 2 is equal to 3/4 times 2 squared plus 1. So it's 4 over 4 is 1, so it's 3 plus 1, which is 4. The derivative of f of 2 is equal to 4. We just have to write our answer. The derivative of the inverse of 3 is equal to 1 over 4.